Well, hello everyone. I think we are live already. I hope everybody can hear me well with my microphone. My name is Mauricio Gomez. I'm the Technical Director of the European Asphalt Pavement Association. I'm honored to be today the host of this webinar on Asphalt 4.0. As you can see, we just finished the previous season in June with the big success of the E&E Congress, and here we are right after the summer break with full energy organizing this new event, this time virtually. For this webinar. First of all, I would like to welcome all the participants who registered for and are following this live stream on our YouTube channel, and also for all the viewers that probably will be watching or maybe rewatching later on this video. For all of you, let me tell you that we have a chat on YouTube that you can use to post all your questions, comments, reactions, and maybe we have some time during the webinar to ask some questions to the speakers. But in any case, all the speakers will have access to this chat as well, so they are encouraged to respond and to react to all your comments and your questions during or after the event. The EAPA communications team is also here, sitting next to me. You can't see them, but they will be also monitoring this chat all along the event. So if you have any issue, for example, with any link that doesn't work for you, if you can't download any of the publications we have on the website, or have any troubles with subscription, etc., do not hesitate to address them also on the chat. So they will be happy to help. And please send them some love as well, because they have been behind the organization of this event, and without them, it wouldn't be possible to do it. If you also like the content of this webinar, I will ask you to press the like button that you will find on YouTube, and also subscribe to this channel, so to make sure that you don't miss any future events, news, and future videos that we post on the channel. In addition, I encourage you to check out our other communication channels, such as the podcast that you can listen on Spotify and YouTube, all the publications available on our website for free, and the EAPA social media channels, including LinkedIn, X, and all the Meta channels, of course, including as well YouTube. And of course, also including the EAPA magazine, which we published on our website around 3 times per year. Okay, at this point, I'm seeing that the number of participants is still increasing on the video. So I'm thinking I would propose that while we wait for everybody to arrive, why don't we show a couple of minutes video that we have, especially for everybody who don't know yet what we do at the EAPA, what the EAPA is, who are behind the EAPA name, and what we do. So can we play the video?
Network has an asphalt surface. There are over 4,000 production sites in Europe. Over 10,000 companies are involved, making asphalt the backbone of Europe's infrastructure. An active and influential European association is crucial to make the industry's voice heard at the European level. Since 1973, the European Asphalt Pavement Association, EAPA, has been that voice of Europe's asphalt paving industry, based in Brussels at the heart of the EU. Over the past 50 years, EAPA's voice has driven innovation, advocated for SMEs, influenced policies, and set industry standards, playing a crucial role in shaping the future of roads. EAPA's specialized committees address key issues like technical advancements, health and safety, digital transformation, leading to critical publications that inform stakeholders, influence policy, and drive growth. With 17 national associations and 29 associate members, EAPA amplifies the industry's voice through European and global collaborations and effective digital communication. EAPA's Euroasphalt and Eurobitume congresses and other events are vital for networking, knowledge exchange, and tackling industry challenges. Through dynamic campaigns, live-streamed workshops, video podcasts, and monthly newsletters, we connect our community, showcase innovations, and attract new talent to a vibrant, future-ready industry. Let's pave the way for the next 50 years together.
All right, so excellent. I think I still get goosebumps every time I see the images from the last ENE Congress that we just had in June in Budapest. And this actually reminds me to tell you that the dates for the next ENE event, which will be in 2026, has been already confirmed. They have been confirmed, so it will be on 11 and 12 June 2026, and the event will be in Vienna. So please save the date, and I hope to see many of you there. Also, before starting, I would like to say a few words about the topic of digitalization and how important this is for us at EAPA. I remember at the beginning, some years ago, that we used to discuss these topics together with the agenda of the technical committee at EAPA, but soon we realized that we were dedicating more and more time to these topics in the agenda. So around back in 2020, we finally decided to take the step and launch an independent committee for what we call Asphalt 4.0. Since 2022, also EAPA has supported an initiative of the Spanish and the Slovenian Asphalt Pavement Associations. This is the annual International Conference on Asphalt 4.0, also known as ECA 4.0. The next edition, by the way, of this conference will be held in Ljubljana in just a few days on 24th and 25th September. And just for your information, all the speakers that we have today in this webinar will be also presenting extended information on this webinar, on this conference in just a few days in Slovenia. So I think you can see now some faces here of the speakers we will have today. But as you know, today we have only 1 hour and a half for this webinar, so they have very limited time for the presentations. In Ljubljana, they will have plenty of time for more extended information, and we will have many more other speakers as well. And precisely to talk about the previous editions of this conference, for all of you that could never participate or even never heard about it, we have one of the most important persons that we have in EAPA on the topic of Asphalt 4.0. He was one of the persons that from the beginning, he pushed us to launch this new committee on Asphalt 4.0 to really boost this topic. He has been actually the chairman of this committee from the very beginning of it. And I would say that even the creator of the first definition of what is Asphalt 4.0, which is the basis that we still have the definition on our website. He is the executive president of ASEFMA, the Spanish Association of Asphalt Producers. And last but not least, until last year, he was also the president of EAPA. So Juan Jose Poti, are you there?
Good morning, Bracer. Thank
Welcome,
you so
Juan
much,
Jose.
Thank you, especially for your nice words. It's too much, but well, thank you.
So it's always a pleasure to have you here. So the first two editions of the ECA 4.0 were held in Madrid.
Yeah.
So you were basically the main host of that, the main, the head of the organization behind. So no one better than you to let all of us know what happened in these first two editions and what this ECA 4.0 conference is about.
Thank you, and congratulations, EAPA, for this webinar. And good morning, for all the people. According to my information, more or less 400 people are registered to see this webinar. Incredible. Well, I give you a short overview. I don't know if I can share. Yes, my presentation. Presentar diapositivas. Yeah. My first presentation. You see on the screen? I don't see my presentation. Oh, yes, I see. Okay, thank you. Well, it's a short overview about the evolution. It's not the case to explain which is what that means Asphalt 4.0. I only invite you to access to the EAPA website. You can find a special section dedicated to explain that. And to give a short overview, in effect, according to the words of Breakshaw, the first and the second international conference were made in Madrid. In 2022 was the first, exactly 20 and 21 September, and the second last year in 23 was 26 and 27. My next minutes will be to explain you, give a general overview about the last international conference. In total, we were involved 32 speakers. And we developed a wide program, different sessions. First opening session is, as always, we are involved 3 people, evidently the president of THAS, my friend Slovenko, me, and the number 3 of the ministry to open the session. We start with the session 1. Session 1 was dedicated to cooperative, connected, and automated mobility, CCAM. And on this table, coordinated by Slovenko Henningman, remember that session 1, coordinated by Slovenko, we participate at a round table, Carsten Karcher, Miguel Caso, and me. Then, before the session 2, Enrique Miralles made a very interesting presentation, explain us the digital tools used by the Asociación Española de la Carretera for the road inspection of the roads in Spain. It's a annual work, and they introduce and they do only now based on digital tools. Session 2, coordinated by Berixo Gomez, presents Yvonne, Nuria Huguet, different Aloya Luis, Rafael Martinez, different subjects in talking about digitalized inspection and evaluation of road condition. Session 3, then a very interesting presentation made by José Miguel Baena. José Miguel Baena is the general manager of City of Madrid, charged of the state of the avenues, the streets, etc. And they explain us the management made by the Madrid City Council to organize the urban payments strategy using digital tools, exactly using big data. In particular, the data come from the company Shova, and José Carlos Valdecantos explain us which is the technology, which is the use, which is the application. Very interesting also. And then Ralph Pomp and other people, Carsten, Enrique Miralles, José Carlos Valdecantos, participate in our roundtable. Session 3, before session 3, Bjorn Zachrisson from NIRA Dynamics. NIRA Dynamics is linked to the group Volkswagen. Talk us about the state of the art of the vehicle onboard analysis and road perception. Then session 3 was technology suppliers and market update for innovative products. Tiberio and session coordinated by Carsten, Thomas Leopold from Key Point, talking about this very interesting subject also. And then I wish to remark Matias Cordero was a very interesting presentation also from Microsoft. Microsoft show us development made based on artificial intelligence applied to the mobility on the cities in the big in the case of big problems. And it's very interesting. Evidently, we know more and more the use of the artificial intelligence was the first thing I heard information of the use from Microsoft talking about the cognitive artificial intelligence applied to the mobility. Well, then Mika Matul, Adrian Cabrera, Martin Fliegel, and José Luis Peña talking at different subjects. Session 4, coordinated by José Luis, digitalization and quality control. Ersun made a very interesting presentation. Also, Aitor Aragon talking us about the use in UNE, Ainor, of the passport, the digital passport, digital product passport. And on the session 6, we have here a very interesting things. It was the pleasure to coordinate, talking about different projects, European projects, involved on the digitalization. In particular, Fernando Moreno explained us the project Masai, Rafael Martinez and José Solís also made their presentation, and Maika Rubio talking us about the the project you do see CircoPub. Well, I wish last session was dedicated to digital twins coordinated by Brexo Gomez. We do two very interesting also presentation, Jorge Salas from Pa de Casa and Aida Marza. Today we have the pleasure to Aida. To finish, only the last minutes, I will to share the evaluation of this second international conference. We ask about the technical quality, and this is the answer obtained. The big quantity of people, maximal punctuation 5 is the best. In terms of organization, similar answer. In terms of what do you find the most interesting session? Congratulations to Slovenko, was the coordinator of the session 1, was clearly the most interesting, talking about the CCAM. And I finished now only the last question was, will you participate next year in Slovenia? And this was the answer. Majority say yes. That's all. Thank you so much. And congratulations again, Mega, Braceo, and all EAPA team. Thank you.
So thank you, Juan Jose, for this information. I think it's crazy how this annual conference on such a specific topic just started 2 years ago with 1 day. We had 1 day in the agenda. Then the second year was already 2 days because of all the papers that we received. And now we will see now what we are expecting for this year, but we have workshops, we have things like that. So it's incredible how this is growing and how very appreciated it is by the participants. So very big success. And if for all of you, for the people viewing this, are already looking forward for this next edition, at least as much as I am, we have also the best person to give us information about what we can expect in this third edition that, as I said before, it will be held in just a couple of weeks. So this person is Slovenko Henigman. He is the Secretary General of the Slovenian Asphalt Producers Association. He is also the Vice President of EAPA these days. And because this year the conference will be held in Ljubljana, in Slovenia, he is behind the organization and all that. So I think, Slovenko, if you can tell us what novelties we can expect for this year, it would be great.
Thank you for this introduction, Brexo. Good morning to all of you, 400 attendees. I'm really astonished. It's great. And I would like to ask Mega to put the program behind, because I'm really very pleased to be the host of the International Conference on Asphalt 4.0 this year in Ljubljana. As you heard from before, we were co-organizer of the first and second conferences in Madrid. And I would like to thank the Spanish Asphalt Association, and of course, special to Juan Jose Poti, who is the leader of this promotion of the digital transformation in the asphalt industry. And thank you for all this work that he did. Asphalt is the most important building material on roads, and roads are the most important traffic infrastructure. There are many issues on achieving optimal user experience for the road users. How to get safer and more comfortable roads while maximizing their capacity. And how can we produce high quality asphalt faster and in better quality and with less people involved in the asphalt industry? There is an answer to these issues. It's digitalization and it is digital transformation. We named the digitalization on roads with the most important material on it, Asphalt 4.0, and it's logical that we organize the international conference on this topic, ISA 4.0. After establishing a program and organization committee, we announced ISA 4.0 and invited a number of experts. We have experts from many countries. This allows us to prepare a very attractive program for the conference with 26 excellent speakers from 9 different countries across Europe who will presenting their papers. There are too many, and I will not go across from speaker to speaker. You see it on the program. We have a great combination of topics connected to the organization of asphalt production and the road infrastructure. We invite the speakers to 8 different topics, and at the end we have 5 sessions which we cover together, and we will have it in 2 days. The first session is speaking about intelligent transport system and cooperative connected and automated mobility, and it will be moderated by Urlik Zurin from DARS from Slovenia. The second session will be project design, digital twins, and digitalization. It will be moderated by Juan José Poti. The third session will be technology suppliers, market uptake, and quality control for innovative products, moderated by me. Then we have the next session, asset management systems and environmental standards, moderated by Brexo Gomez Meide. And the last one is the session number 5. You can see it on the screen. A new generation of asphalt production. At the next screen, please. Yes. New generation of asphalt production, asphalt laying and safety at work zones, moderated by Matthias Martus. With an additional invited lecture from Roberto Nunes del Rio, discussing his book and experience in digital management and user experience on day 1, and the workshop on day 2 from companies Padecasa and Xoba from Spain, QPoint from Switzerland and Austria, and DARS from Slovenia, covering how they use their technology in real terms along with the live demonstration of digitalization. That means we will have a special workshop where you will be able to see how we use digitalization in practice. And this is the most important thing. There will be also a big exhibition place with many possibilities to discuss with our exhibitors, as well as conference participations. At the moment, we have 12 exhibitors. However, new exhibitors are still being finalized. I think there are many reasons to join the conference, and I'm really very pleased to invite you to the beautiful city of Ljubljana, to the excellent Grand Union Hotel, which is located in the city center. If you don't have the possibility to physically join the conference, there is also a possibility to join us online across the streaming service. If you need additional information, you can get them from ASEFMA, from the Spanish Association, from EAPA, but the most, of course, from us, from ZAS, on our website, or from the ZAS team, which is available for you. So wish you to come to Slovenia, and thank you for listening. Thank you.
Well, thank you very much, Slubenko. I think no doubt it's going to be a great conference. As I said before, it keeps growing and growing and being better and better. So I'm really looking forward to see you there. I'm looking forward to see many of the participants that we have today here on this webinar. I'm seeing on the comments a lot of greetings from many countries, from Turkey, from Bulgaria, UK, Brazil. So this is really nice to see. So, okay, Juan José, Slubenko, thank you very much for all this information. It has been really useful, and see you soon.
See you.
Okay, and so we are already a bit behind, slightly behind the schedule, so I wouldn't want to lose more time. So with this, I think it's time to continue on the program. And the first speaker we have today is Ersun Gürener. He currently holds the position of Senior Manager Sales at Infratest and serves as the CEO of Infratest Digital Solutions. He has authored a wealth of articles and is a regular participant in technical conference and events. Ersun's professional profiles also include active memberships in associations in the field. For example, he's a very active member of the technical committee and the Asphalt 4.0 committee here at the EAPA. So Ersun, it's a pleasure seeing you again.
Thank you very much, Brescio.
And the floor is yours.
So, good. Perfect. Okay. Now, ladies and gentlemen, also welcome from my side. I'm happy to be one of the presenters here in this webinar, and thank you for being here. And also thank you for the surprise when you asked me to present only in 8 minutes. This is really a big topic to present these type of things in 8 minutes. So to be honest, you can only get a small hors d'oeuvre, a small appetizer. Everything else, I think, can be heard perfectly in 2 weeks in Ljubljana, where we have a little bit more time. So starting with the presentation, of course, when I was sitting there and saying, okay, how to fix this big, interesting topic in 8 minutes, first idea was, okay, we can start like journalists start with the 5W plus 1H type of questioning. So what is the topic we are talking about? Who is involved? Where is this happening? And when? Of course, this is, for example, the point. When? It is yesterday. About this topic we can talk hours by hours, and why and how. I think you all know why these type of things are important, and that's the reason why you are here and following this webinar. So from all these interesting points, I can only pick a few of them and give you a small overview. Coming from my profession as a civil engineer who's working with a lot of these materials and with machines, of course, for us, digitalization in road construction is always according to quality control. And when you talk about quality control, then you have in total 3 pillars. One of the most important is mixed design, then the production control, and of course, the field control after the paving. Today, we will only talk about the third pillar, the field control after the paving. So what are we doing in this case for quality control activities during and after paving? Of course, it starts with measuring of the asphalt temperature during dumping, sampling of the asphalt, core drilling, etc., etc., etc. Talking about all these topics would take minimum 30 minutes. So I have to pick one, and it is in my importance still the most important thing for hot mix asphalt. It's the temperature measurement, during and after the paving. Why is it important? So during the mixing, temperature is important because otherwise when you start mixing with too low or too hot, you can on the one side destroy the bitumen, or on the other side it can be so cool that you are not able to compact the asphalt. Paving temperature is also very important. It's important to monitor this temperature, that you exactly know where are the fields where I can go and compact the asphalt, or where I'm ready with the compaction and it's not necessary or not good to compact. These are, for example, fields where you will find a lot of presentations and exhibitors in Ljubljana, where this topic is really figured out perfectly. Traffic release after paving. This is very important because a lot of things changed, and this is one of the parts I would like to talk about. And the vertical temperature distribution, because I think we all face this. We have a climate change, and the question is, what is the effect of the climate change on our road network? So coming to the point of traffic release. Sometimes every minute counts. Imagine you are a municipality and you pave the road, and you have to decide, can I open it or not for traffic? And actually, how it works nowadays, this is, for example, from the standards which we have and which we use in Germany. Our traffic release system until now is experience-based, and experience-based, we say after 24 hours or in special cases after 38 hours, you are able to open the road again for traffic. But the question is it really right to do it in that way, especially in a time where we have very warm nights? In former times in Germany, it was easy. Even if the day was hot, the night was always very cold. But this changed a little bit in the last years, and we are facing a lot of problems according to this. So it is important and mandatory to know the core temperature, to know and measure the core temperature, and to decide directly according to the values you have, is it good to open it or not? And this is something we can do with very, very ordinary and not new things like cable sensors, which we can connect to a special data logger and transfer this data directly to your mobile, for example. And you can sit in your office and you can directly decide and say, okay, the asphalt or the layer is cold enough, and you can open it now for traffic. Of course, once you are in the environment of hot mix, then you have to take care about that you use good materials, special cables, for example, because your asphalt can be very hot. It can be in hot mix asphalt up to 160, 170 degrees. In future, it will be less, but you still have products like mastic asphalt, for example, which we use in Germany. There it can be up to 220 degrees. So you have to take care that you have the special equipment for this. And then everything at the end is easy. You get directly the temperature profile in the layer. This is, for example, a project which was done in August last, I think, two weeks before. It's a binder layer based on asphalt concrete. And as you can see, it took from, it started at something like 8:30 with 140 degrees. And within the first 2 hours, you reached temperature profile like 65 degrees. But interesting, even after hours, here, for example, at something like end of the day in the night, you have still 40 degrees. You have still 40 degrees in the middle of the layer. And if you check the day after, you reach 30 degrees at approximately 10 o'clock in the morning. So these are things you have to consider. And what is the reason for this? If you take a look to the ambient temperature, it was 2 days where you had where you have had hot weather. During the noontime, you had up to 33 degrees. And even in the night, it doesn't cool down. So you have up to 30 degrees in the night. And because of that, your layer is not able to cool down until 20 degrees. So what is important? You have to take care that you really measure in the middle of the layer, so that you have the right values, especially at the beginning. For this, you can use special setups where you guarantee that your sensor is really in the middle of the layer. So this was, I think, a standard technology which should be standard to use to measure what is happening during the cool down phase. And of course, it's very interesting to know what is happening later on in the asphalt package, not only in one layer, in the complete asphalt package, and to see what is the temperature distribution and what is the effect of climate change, which we are forced. So for this, the idea was to create an artificial core, which has sensors which are able to monitor the temperature starting from -1 centimeters down to -25 centimeters, to measure this value, to save this value, and to transfer this value to the cloud. So how does it work? You take a core drilling machine and drill a hole into the existing pavement. This is important, existing pavement, 70 millimeters. Then you place the IDS or the drill core into the drill hole. You backfill it with a resin so that it's really tight and fixed in the existing pavement. And this is at the end how it looks like. So the interesting thing is, we are in an industry where it is very difficult to close the road for traffic. So you need systems which transmits the data wireless to the cloud or to the internet. And in this technology, which I've shown to you here, between the sensor, which is in the pavement, and a gateway which you need, there can be a maximum distance in open area up to 15 kilometers, and within cities up to 2 kilometers. And during this time, or during the lifetime of the sensor, you have 24/7 data transfer. This is how it looks like. This is an example in front of our factory. As you can see, the sensor is placed directly here. And it is interesting that the shadow of this tree during the noontime is directly on this sensor. And as you can see here, you can see directly also the effect of shadow. In this case, it's approximately 10 Kelvin directly on the pavement and on the lefts. And this is, I think, a very interesting method to have long-term data and to see what is happening in my asphalt package, especially in the vertical temperature distribution, and to understand what is happening because of shadows, for example, and in different climate zones. So I know 8 minutes are over, and this is really my last slide. I hope that I see a lot of you in Ljubljana, because in Ljubljana, as said, we have a lot of time, and we will be able to present a lot of more new type of technologies and what we can do according quality control in the roads. Thank you very much.
Okay, Ersun, thank you. Thank you very much. I know very well what Ersun does. At EAPA, we are now producing a couple of publications on Asphalt 4.0. Ersun is being active, especially on the part of how digitalization can affect or can improve the work at the laboratory for quality control. So I would like you to speak much more about all this, but thank you for this glimpse of what you are going to present in Ljubljana. And for the rest of viewers, please, if you have further questions, just use the chat on YouTube. So in order to continue with the program, I would like to introduce our next speaker. He is Jose Carlos Valdecantos. He, after working in different companies, he is now the CEO of Shoba, a company focused on data science for safer roads. The work they do, transforming data from vehicles into a powerful tool for the road asset management, is, to me, one of the most disruptive innovations that we have seen in the last years when it comes to the asset management of our road networks. So, Jose Carlos, I have been seeing you in different workshops and meetings, and it's a pleasure having you here again and explaining what you do for all the viewers. So the floor is yours.
Thank you so much, Rachel. Thank you for the opportunity. I am going to present about a project we're doing in Spain, in Madrid. As Rachel explained, we work with connected vehicle data. By connected vehicle data, we mean the data that we can extract from normal vehicles, any kind of vehicle that is providing information into the cloud about the different data that the sensors record. I don't know if you can.
Having some issues with the connection from Jose Carlos, or I think it's his connection. I hope everybody can hear me well now. So we will try to reconnect to him a bit later on. So let's skip him for a minute and move on to the next speaker, who actually is myself. So I don't know if we can share my slides. There we go. Okay. So what I want to present on this occasion is the decarbonization roadmap of the asphalt industry, and I will relate it a bit on how Asphalt 4.0 technologies can actually impact on what we do for the decarbonization strategies. If we move next slide. So this is a document that we have published very recently. Actually, it was during the ENE Congress in June this year. So just a couple of months ago, is kind of coming out of the oven. And I have to say, it has been so far a big success. We ran out of copies during the event, and also we are having a lot of downloads from our website. And this is why we wanted to explain a bit about that. The document that you see on the screen is a 8 pages document. It's a briefing of, or a summary of, a lot of work that has been done at the EAPA over the last couple of years, I would say. And we are now working on an extended version where we have included all the information about calculations, all the explanations about background data, the methodology, etc., etc., etc. So all these will come soon as well to the EAPA website. This is an exercise that we started after the European objectives of decarbonization. As you probably, many of you will know so far, we have in Europe the objective of reducing our greenhouse gas emissions 55% by 2030. This is compared to the values of 1990, so not to the values we have nowadays, but 1990. And the other objective is to have net zero emissions by 2050. So what we have done in this work with this exercise is to try to see what is the strategy that we need to undertake in the industry to make sure that we meet these objectives. For that, next slide, yes. For that, we have followed a 5-step methodology. First of all, we had to calculate what were the emissions that we had in 1990, which was the reference year. We calculated then the emissions that we have nowadays. We have to see where we have to be in terms of emissions in 2030 and 2050. Then we have seen the decarbonization potential of different technologies. For example, what happened if I have a 5% reclaimed asphalt content in our mix, and then I increase to 10% or to 20% or to 30%. Let's see what happens with emissions. And we have done the same thing with different levels of implementation of warm mix asphalt or replacing fuels in the asphalt plant, etc., etc. And knowing where we were, knowing where we have to be, and the decarbonization potential of different technologies, then we define a strategy, the levels of implementations that we have, what we need to have on different technologies by 2030 and 2050 to make sure that we meet the European objectives that I mentioned before. On the next slide, this is the methodology that we used was based on the EPD methodology, the Environmental Product Declarations that we have in Europe, based on the standard EN 15804. Second Amendment, and for that we have included the impacts during all the mandatory modules according to this standard of the service life of asphalt. So this includes module, for example, A1, the raw material supply, A2 is the transport of the materials to the asphalt plant, A3 is the impacts during that happen at the asphalt plant, A4, which is the transport of the mix to the job site, and A5, which is installation of the mix at the job site. These two are optional, but we included them as well. And then also the mandatory modules at the end of the service life, including what happened if the mix is reused as asphalt or is recycled as something else, or if it's disposed in a landfill. So what we have found is that the current situation, what we have nowadays, it's that in order to produce a ton of asphalt, we need to emit or produce emissions of around 65 kilos of CO2 equivalent. In this graph in the left, you can see the contribution of each of these modules. And something interesting that we can see is that modules A1, A2, and A3, which is a cradle to gate, or the impacts that happen before the mix even leaves the asphalt plant, contribute already more than 80% to the total emissions. So more than 80% is very significant, and it tells us that whatever technique or technology that we have that can contribute on these stages is going to be welcome, let's say. So here in this graph, we can see the situation that we have in 1990, the first block, the gray block. than the situation that we have nowadays, that as you can see, we are already 36% less of emissions compared to the reference year. And then how implementing different technologies, we can actually reach in 2030 a 56% reduction, which is more than the 55, which is the European objective. Repeating again the same exercise by 2050, and the next slide, we can see that actually we can reach a reduction of 100%. Actually, we were aiming at 90% because we are also considering that some other developments, not necessary to the technology that we have nowadays, will also happen in these coming years. So actually, we aimed for at least 90%, understanding that there will be other things, for example, the decarbonization of the electricity production or things like that, that will happen over these years. But with the technologies we have, and also, as you can see, we have more technologies that we have included here compared to 2030, because not all these technologies are feasible for in 6 years. But with that, and increasing certain levels of implementation of, for example, circular economy, low temperature, replacing fuels in a more, let's say, in a farther way than in 2030, et cetera, we can actually reach this objective as well. In order to see where Asphalt 4.0 can contribute, I would say that the main points are to produce a more efficient transport of the materials. Asphalt 4.0 can improve really the logistics of the transportation, really create a synchronization between, for example, the asphalt plant and what is happening in the job sites, and take into account, for example, traffic delays, disruption, et cetera, et cetera. So this is something where Asphalt 4.0 can help a lot. Of course, increasing the efficiency in job sites and at the asphalt plant. For example, what we are seeing now, this is smart roller compactors that if we have to pass, let's say, 5 times in every spot of the road, the operator with the new technologies can know exactly if it's being 4 times or 5 times or 6 times. So to make sure that we don't pass, let's say, 7 times in order to make sure that all the points have 5 or things like that. That used to be the case. So this kind of new technologies are also helping to be more efficient. This is a different way of representing the roadmap. As you can see, the situation where we were in 1990, where we are now, and the progression that we are expecting for the coming years, and the level of implementation of different technologies that you can see in the table below. And last but not least, in this document, we also have a call for a collaborative responsibility. Here we are saying that the challenges ahead are big and that the industry is doing a lot, but we are still having a call for collaboration, for example, with the road administrations and with policymakers in order, on a series of things, for example, in order to create a higher demand or a greater demand for technologies that we already have available in the market, but they don't have yet the demand that they should, or what we think. And for example, for the industry, also to continue developing all these technologies as we have been doing, and also many more in order to meet all these challenges. For other sectors different to asphalt, we also have some calls, for example, to supply low carbon raw materials for the decarbonization of energy sources, or for example, the decarbonization of the automotive sector. And with this, I reached the end of this presentation. If you found this publication interesting, this is the QR where you can find where you can download the document. You can also see it now at the bottom of the screen. And if you need more information about it, don't hesitate to contact us and ask questions immediately now on the chat or further on our contact channels. All right, so I don't see any immediate question on the chat. So I hope we have Jose Carlos back with us. Jose Carlos.
Yes, thank you, Bracio. Sorry about that. I have a better Wi-Fi connection probably now. I'm going to be very brief. I think I can. Okay, I think we can recover the lost time. Okay. As I was commenting while I just introduced before, we work in Suba, we work with connected vehicle data. Connected vehicle data gives to the road authorities the opportunity of acquiring nearly instant feedback of the effect that their actions have in the cars, in the drivers, which are the users of the road. And in this case, we are going to present in Ljubljana about a project we have in Spain, in Madrid, having to do with the emissions. Our company works with many different kinds of data, and normally emissions wasn't really a big part of the. We didn't see a lot of potential at the beginning, but we are finding that the road authorities are under a lot of pressure to show that they are caring for reducing they are taking action to reduce the footprints and the emissions. So in this case, we have SEIT. SEIT is a part of the Spanish ministry. The 3 levels of government would be like the top, the federal government. But although it's in the ministry, it's a smaller. It manages a small segment of the ministry's network. It's high capacity roads having to do with tolls. So them being the ministry, which the ministry in Spain is quite an innovative authority now, the last few years, and say it being a smaller part of it, they have a lot of flexibility to be fast and actually to implement a project like this. It has been quite single for them. You can put the next slide. Okay, so basically what they want to do is they are repairing a road that has very bad pavement for the past few years, and they want to say, okay, is paving the road going to reduce the emissions? They're hoping they are. There's some literature that comments that creates an expectation that it does, and there's some testing done. But in this case, we want to do it having a lot of data, not just with some probes. But here in this case, we wanted to do the exercise. Can we really test how much feedback can we get? So obviously, the most important part of it would be first the variable that we want to check is the consumption, the fuel consumption, which is a data set that you can acquire from several thousands of vehicles, plus also the roughness. So obviously, we want to see that. In this case, you're going to see in the next slides, but the roughness is improving a lot in this road, so we can estimate that the consumption will go down. So all the variables that I mentioned in the previous slide, we check for traffic, for speeds, we check for fleet composition. That is, in this road, we have some cameras that can recognize the license plates. We have a huge database of millions of registers, and we send them to the DGT, which is the traffic administration in Spain, and they give us back, not obviously the owner of the car, but they give us the year, the kind of combustion, is internal combustion, is it diesel, a lot of information of each car, of each truck. So with that, we can characterize, we can identify what is the fleet composition. We have, if you can show here as well, the fuel consumption. That is another data set that we acquire. The cars, some of the cars are sending their fuel consumption every few seconds, so it's milliliters. This actually was a bit of a problem for us because the data, there was a mistake at the beginning in the data, it was coming in gallons, not liters. Well, we had a bit of an issues there, but anyway, we have that sorted now. Next slide, please. Here you can see, well, maybe it's not that evident to everybody, but the cars are scanning the surface of the road every day. In this case, we are getting data from Aerodynamics, which is a fantastic company belonging to the Volkswagen Group. And they supply us with daily measurements. And if in this case, you can see that is one of the lower ring roads of Madrid, the M50. The blue is like a good roughness, good surface, good IRI. The red will be very bad. So if you go to the next slide, we are analyzing there a segment. You can see on the right side of the image, you can see like 2 points in magenta and in green. Well, that's the start and end point. That's divided in 77 small microsegments. And you can see in that graph, we are seeing in the Y column, it's the weeks. So it's, in this case, it's the last 6 months. So you can see on the right-hand side of the graph that it has gone from yellow, going down through the year, along the year, to blue. So there you see like a big shift in color in July. That's when they paved, And in the linear graph at the bottom, you can see like there's a big descent coming from an IRI of around 3. And in July, it goes down to an IRI of around 1, So now we have that improvement, and now we have to get the data from the fuel consumption. Is that improvement creating a lower consumption for the same conditions of, obviously, of traffic velocity and other things, So that is the work that we are doing, and we're going to present more in depth in Ljubljana. Thank you very much, Rachel.
All right, thank you, Jose Carlos. As I said, very, very interesting every time I see one of your presentations. And thank you for this glimpse. Indeed, Jose Carlos will be presenting, I think, 2 different presentations in Ljubljana, plus you will be participating in a workshop, a more practical dynamic workshop where you will be showing us live how to use the tool and et cetera, et cetera. So I'm really looking forward for that. And for everybody, if you have questions, please use the chat again. Jose Carlos will be there. All right then. So thank you, Jose Carlos, and we move on to the next speaker, who is Ulrich Sorin. He is head of the development of new technologies at DARS, the motorway company in the Republic of Slovenia. He is currently completing his doctoral studies in the field of introduction of artificial intelligence for predicting motorways traffic jams, and he is also lecturer at the Faculty of Civil Engineering, Transportation Engineering and Architecture at the University of Maribor and president of the Society of Traffic Engineers of Slovenia. So Ulrich, thank you for being here, and the floor is yours.
From my name is Ulrich Zorin. I'm from motorway company, so I have some slides. What will I present in Ljubljana? So I'm more focused on the ITS, on the digitalization, and I will present what we have in Slovenia on motorways. I think the systems are the same in other countries in the world. So I want with my slide, with my presentation, just present what we are doing, motorway operators, regarding to the traffic management, traffic informations, communicating infrastructure with car with infrastructure, car with car, and some words also about international traffic management, because Slovenia is a very small country, 2 million people, and we are very, very good connected on daily basis with our neighbor countries. So if something is happened in Slovenia, we must coordinate the traffic with our neighbor countries. So we all know traffic counters, so we collected the traffic data with the counters. In our case in Slovenia, we also use the traffic counters for detecting the wrong way drivers. So with the counters we have in the road installed, we detect in real time the wrong way drivers, and then we send the alerts to the users via application. We have our own application, and then we can send the information also with via radio stations, VMS, CITS. So this is the new system for detecting the wrong way driving, and this system is very good and very fast. We communicate with the users with our application and VMS. You know, all countries using VMS portals on the motorways, where we have also installed the microwave counters. So on each lane, we have this kind of microwave counter, which collect also the same like the loops. So speed of the cars, the shape of the cars, the type of the traffic, the distance, driving direction, and so on. On the whole network in Slovenia, we also have the system for weight in motion. So we know anytime we know where we have overloaded trucks, we have this system connected with the police, and we can stop any truck which is overloaded. The tunnels, this is the big issue in all countries in the world. I think the tunnels very dangerous objects, infrastructure objects. So we have in the tunnels a lot of different ITS systems. This is one picture from Karavanke tunnel, which is between Austria and Slovenia, where we have on the both sides a thermal scanner where we scan the trucks if they are overheated. Weather stations, so on the whole motorway network, weather stations to collect the weather data, and also this system is connected with our maintenance guys, and we are collecting with this system also the temperature of the surface. Traffic management systems, this is also a big system in Slovenia where the traffic management systems manage the traffic in real time. So some programs are working automatically. So if the system is detecting, for example, fog on the road with the weather stations, the system can switch on the motorway program, which inform the users that in the direction they are driving is the fog and the speed limit is lower and so on. So we have automatic programs and manual programs which are handling with help of our traffic managers in the control centers. Traffic Information Center, our company is managing also the Traffic Information Center for collecting and sharing the traffic information from all national roads. We are sharing the information with our application, Promet Plus, where the users can get all the informations. Last year, we started also to use the machine learning because we have a lot of information, traffic information, weather information from neighbor countries, for other traffic systems in Slovenia, so we can't handle all this data. And we started last year to implement the machine learning, and with help of these machine learning models, we can predict the traffic regarding also, like on this picture you can see, regarding also how many ships are coming to the port of Koper. So we will collect the data from the Adriatic Sea, so we can predict how many containers will then go from the port to the motorway in Slovenia. Section control radar system, so we will implement in the next 2 years section control on the all 4 motorway connections which are going to Ljubljana city. CITS, this is the new ITS system we have on the motorways in Europe. Cooperative ITS systems. This means that we are communicating with the cars directly on the motorways. So without control centers, we can send the data from the weather station, from the VMS, from the counter directly to the car. So we are doing this on the 2 ways, hybrid, so microwave detection and mobile phones with our application Promet Plus. So this was very, very quick, very short. What will I spoke on in Ljubljana on this our event in September. So I'm happy to share you this much more detailed than on the event. Thank you.
Okay, thank you, Ulrich. Thank you very much, and see you soon in Ljubljana. So for everybody, please send the questions on the chat, and let's move on to the next speaker. The next speaker is Natasha Puran. After finishing her technical studies at Delft University of Technology and completing 10 years of experience as a research consultant, in 2023, Natasha, together with her business partner, founded the consultancy NBSP, Partners in Solutions. In this, they have been combining knowledge of both theory and practice to design and optimize research projects, processes, and their interrelations. So, Natasha, welcome, and the floor is yours.
Good morning. Thank you. Hi, good morning, everybody. thank you to EAPA for inviting me to have a short talk here. We have little time, and I think I still have too many slides. So let's power through, and let's hope you will join us in Ljubljana in September this year. So what I will talk about at ECA this year is a fundamental framework for functional validation of pavement performance. And that's already a mouthful, but it gets way more complex after this. But it's mainly fueled because of all the transitions that we are facing, not only as a pavement community, but also globally. And we see three main topics: circularity, digital transition, and technological transition. And they are all interconnected. And with that, I mean that, for example, by the way and the speed at which technology is progressing, we are able to measure more and we are able to measure better. Digitally, we are improving ourselves, so we are able to analyze more, we are able to get smarter, quicker. And circularity, well, our climate actually makes us have circularity and environmental impact to become a new generation of fundamental specifications. We have to become more sustainable. And we have to go through all these transitions successfully at the same time. In the meantime, every time we, for example, have a breakthrough technological innovation, it can help us digitally and in circularity. So there are interactions there. But at the end of the day, all we want to do is be able to manage the performance of our pavements throughout the entire life cycle of these pavements. And as I said, there will be a lot of schemes, so I will try to be quick. But if we talk about performance and managing performance, then it means in the basis that all we want to do is to be in control of quality, and not quality at a certain moment in time. No, we want to be in control of the quality throughout the pavement life cycle. And I don't know if you can see my pointer. But here at the bottom of the slide, I have made a summary of pavement life cycle. I think if you talk to different specialists, we will get a lot of different phases in between. But in summary, we want to know that in the design stage, we are specifying pavement designs that will fit our expectations of the performance that we want. We want a pavement to have a certain lifespan. But when we construct this pavement, a lot of different factors come into play that might cause that we do not realize what we specify. Does it mean then that what we have realized is not fit for purpose? Is it less fit for purpose? Or is there no significant change in the way this pavement or this object fulfills its purpose? These are all questions that we are facing now, because at this moment in time, we are not able to make, for example, a surface life prediction, not theoretically and not preventively for a pavement that already exists. We are not quite clear yet on how we should do adequate performance monitoring, because we're not really sure what type of aspects are really key to making the performance of the pavement. So what we do know is that from every time we realize a pavement and we use a pavement, we go through these life cycle stages. And by going through these life cycle stages, we perform activities. and that activity that transforms our object, for example, our pavement or a pavement layer, which causes the pavement or the pavement layer to enter a different stage. And during our activities, we have a clear purpose with all the activities that we apply. So if we take for the life cycle only the construction and the delivery and the user monitoring phase, and we try to really make this relation explicit, then we get to this slide. And I propose that in Ljubljana we will get into more detail about this, because this is a lot to go through. But what you can clearly see is that with quality as a basis, and acknowledging that you always have an input and the process that you have, in which you have to be managing your quality, there's a structure that can be determined of the entire life cycle of the asphalt pavement. And as you see here, there is this learning loop, because if during the construction phase we gather relevant data about all these steps, then we have sufficient and adequate input to, for example, make good predictive maintenance models or asset management models. We also have input and data for making performance models, but also to improve our performance-based specifications or our design methods. This is a learning loop that will not take place and will be complete and perfect within a year or a matter of years maybe. But it's my opinion that as a pavement community, this type of framework will help us to understand what we are doing more explicitly, and it will allow us to share our data and share our knowledge and interests. So we will be able to reach, for example, those ambitious climate goals. This I will skip. Well, and if we want to share all this data, because you can imagine that if for this small part of our life cycle, the deconstruction yields this type of matrix, then we will produce vast amounts of data. And it will mean that we need to be able to communicate this data with each other. So main message, semantics matters. And to make sure that our data is semantically interoperable, we in the Netherlands, at least, we are working now on an ontology that will allow us to do so. If you are interested, please also read the paper Road Infrastructure Knowledge Graph, the beating hearts of a common data platform, which in detail covers this topic. And then if we put everything together, this is a visual representation of the basic framework for the as-built state. And as you can see, in the future, based on this analogy, for every phase in the life cycle, we will be able to expand this functional framework. So, to conclude, I have listed here some conclusions that are also in the paper, so I will not address them. I will invite you to read them. And what I also wanted to mention is that we are now building this fundamental framework in what we call transition path sustainable roads. And this is something that corresponds with an EAPA publication, which urges the development of an umbrella initiative for coordination and governance. This transition path is in the Netherlands supposed to be this umbrella initiative. So if you want more information about that, please come to Ljubljana. Thank you.
Yes, great message, Natasha, to finish this presentation. Excellent. Thank you very much for these insights, and I will see you soon as well in Ljubljana. Thank you very much.
Thank you.
And with this, we will reach the last speaker we have today. She is Aida Marzán Beltrán. Aida, can I see you? Yeah, there you are. So since 2016, Aida has been working as a standardization, quality control, and research development innovation assistant at BEXA, at the Asphalt Laboratory of BEXA. Aida participated in numerous projects and has published valuable contributions to Spanish and international journals on a wide range of topics. As an interesting fact in her CV, the Spanish Association of Asphalt Producers, ASEFMA, granted Aida the Asphalt 4.0 award in 2 different occasions, actually. So Aida, it's a pleasure having you here, and please, the floor is yours.
Okay, thank you, Horatio. Well, I'm grateful to be part of this webinar, so I would like to thank the EAPA team for inviting us. I'm going to do a review of the existing technologies for road pavement condition monitoring. First of all, as introduction, I would like to say that the road maintenance sector is a user or a consumer of digital technology. We use technology already developed that in most cases is adapted to our particular purposes. The main technologies used in our sector consist of 3 big blocks. The data acquisition, which is considered the first pillar of the concept Asphalt 4.0, the data collect and storage, and the data treatment. In the following slides, I'm going to explain one by one, showing the main technologies existing at the moment for each block. Regarding data acquisition, there has been many improvements in the last decade in reference to the tools used to acquire large amounts of data. This means a big leap regarding the traditional maintenance. Chronologically, EOT systems were the first tool used. It consists on including fixed sensors or onboarded technology in a vehicle that allows us to acquire data continuously. Then, smartphones increased the number of sensors integrated, such as cameras or accelerometers, which were the most used. After that, the last vehicles have multiplied the number of sensors per 10, so this allows us to determine parameters such as the state of the pavement, its roughness, and its resistance to sliding. Next slide, please. Thank you. The second block is a process that allows to transmit all the data collected in the first phase to a server in the cloud. It has 2 crucial elements, which are the communication technology that has experienced an outstanding progress in the last 20 years, increasing the transfer speed from 9 kilobytes per second to 1 giga per second. And then the data pipeline that enables automated and orderly collection of millions of data. The last block consists of processing all data obtained to identify patterns which will lead to optimum decision making. It constitutes the second pillar of the concept Asphalt 4.0. On the right of the slide is shown the steps followed in this block. In the first step, data is pure to get high quality data. In the second step, correlation algorithms are applied among the sensor data to get understandable information for us. And at present, in the last step, artificial intelligence algorithms are being applied as neuronal networks, trying to be corrected by themselves. Okay, to end with my presentation, I would like to show you PubDT, which is a system that integrates all of the blocks I have mentioned before, onboarded in a conventional vehicle. It consists of a road auscultation system that measures the IRI from 2 accelerometers. It's capable of showing the evolution of the RI continuously and in real time for each section, and through artificial intelligence make evolution forecasts for the next 3 years and a proposal for actions. It's also capable of detecting the defects of the pavement and classify them. And all the information can be shown in a platform and located in a map. And if you want to know more, I invite you to join us in Slovenia the 24th and 25th of September. And here you have my contact details. Thank you very much.
Well, thank you, Aida. Thank you very much. I can't see yet the contact details, but I think I missed that last slide. But okay, thank you very much, Aida, and for keeping the time. Thank you all the speakers for being so good at keeping the timing. We still have a couple of minutes left to thank you all for the contributions. To remember everybody that if you like what they have presented today, this was just like the trailer of the movie. There was just a glimpse of what they will present actually on 24th and 25th September in Ljubljana. I hope to see many of you there in just a few days. And as promised, very important, all of you, all the viewers that have registered for this webinar, you will receive soon a 10% discount code for the registration at the EAPA 4.0. And for all of you that have been watching without registering, because maybe you didn't know about this promotion, make sure that you subscribe to our newsletter and our communication channel so you will not miss this kind of opportunities in the future, and also many more news. This is all for now, I think. It's been a pleasure. If you like this webinar as much as we enjoy doing it, please don't forget to hit the like button that you will find at the bottom under the video, and to make sure that you subscribe to our channel for more events, for more live streaming, and more videos that we are already planning for the near future. Thank you, everybody, and see you soon.
Thank you.
Thank you, Brexo. Bye-bye to all of you.
Bye-bye. Thank you.